So what we have here are two metallic spheres, and we're going to be talking about charging by induction. Now, when we have something metallic, it's really good at either giving away electrons or taking in electrons. Usually, if you look at the periodic table, metals tend to give away electrons. So, in electricity and magnetism, they're called essentially a material that can conduct electricity, or conductors, because they allow electrons to flow through freely. It's kind of like in chemistry where you learn about valence electrons, so it's that. Basically, metals have valence electrons, and they need a lot of valence electrons to fill up their shell, so they're like, you know what, might as well give away electrons because that's a much more easier way to clear out their valence shells. So yeah, these are just metals. They're called conductors because they can conduct electricity. Why can they conduct electricity? Because of the fact that they allow electrons to flow through freely. How do they allow electrons to flow through freely? By giving away electrons. Metals are electron donors, as you learn in chemistry. So these are two metallic spheres, and they're touching each other. Now we bring in a glass rod that is positively charged. Glass rods are insulators. They don't allow electrons to flow through. So if an electron is flowing towards an insulator, it'll stop at some point. It'll stop moving. Now we brung in a glass rod and we kept it at a distance between two spheres that are touching each other, two metallic spheres. The glass rod was positively charged. So I'll draw something here. Sphere A, sphere B. When you brung the glass rod at a distance from the two touching metallic spheres, this created a dipole. Basically, this is kind of like similar to a magnet, where since you have a positive charge on this side, though this sphere here is neutral, the fact that there are positive charges on this side, they'll sort of push away electrons inside this metallic sphere towards its right-hand side. That's wrong. They'll attract electrons towards the left-hand side inside the sphere. So the electrons will naturally move more into this area of this sphere here. And what's left over on the other side are positive charges. So now the sphere here is no longer necessarily, it is still neutral if you account for the net total charge. 3 negative charges, 3 positive charges, but overall it's still neutral. This is called inducing a charge in a sphere, in a metal conductor, because this positively charged material came close enough to a metallic sphere that it caused charges to move inside the metallic sphere and form a dipole. So negative charges were moved to the left hand side of the sphere, and positive charges were moved to the right hand side of the sphere. Now that's great. So we induced a dipole. In this question, sphere A is also connected to sphere B. So something similar is going to happen here. We started with two spheres touching each other, then you brought in a glass rod. And then what I'm explaining to you is how we get from that step to here. So now, since this guy has a dipole, the positive charges are going to sort of, on the right hand side of sphere A, will repel the positive charges in this second sphere, especially because they're touching each other. So they'll move here to the right hand side, and the positive charges will actually also attract the negative charges in the sphere. So the electrons are going to move closer like this, and these spheres are touching. So now what's going to happen is, since these spheres are touching, electrons can flow between these spheres until they sort of become neutral. But at the same time, I also have the glass rod close enough to both of these spheres. So I have to keep these two things in mind. The fact that electrons can flow between these spheres, but also that these positive charges in the glass rod are still have an influence on both of these spheres. So now what's going to happen first is that electrons are going to flow in these two regions of both of these spheres. Specifically, what's going to happen is the electrons in this region of sphere B are going to flow into sphere A, because these two spheres are touching. Okay. Until they neutralize this region here of sphere A. So we have 3 electrons on the left-hand side of sphere B. They're going to flow into the right-hand side of sphere A and neutralize the right-hand side of sphere A. So this electron flows here, neutralizes that one positive charge, and then the same thing happens for this electron and this electron. So eventually what we get is this. I'm showing this process to you one step at a time. So now what we've done is we've neutralized the right-hand side of sphere A and the left-hand side of sphere B. Why? Because the two spheres are touching each other, hence allowing electrons to flow between them. Again, they're metals, so they like to, if they have 2-3 valence electrons, they'll just give them up, they'll donate them. So that's what sphere B in this scenario did. It donated those electrons. It didn't want them. Sphere B made its left-hand side neutral, and also helped sphere A with making its right-hand side neutral as well. So now this is kind of where we've gotten to. We've gotten to this stage here. Now the spheres are still touching, but the idea is that sphere A has only negative charges and sphere B only has positive charges. And we still have our glass rod here, which is at a reasonable distance away away from spheres A and B. So now that we're at this stage, we're gonna keep the glass rod here. We're not gonna remove it yet. So what happens is that sphere A and sphere B sort of push each other away. They lose contact. Why and how does that happen? The glass rod is positively charged and sphere A is negatively charged. That means that the glass rod will attract sphere A, and sphere B is only positively charged. So the glass rod is sort of repelling sphere B because like charges repel. So the glass rod is pushing away sphere B, and at the same time it is attracting, pulling sphere A towards it because sphere A is negatively charged and opposite charges attract. And because of these two kind of forces, the glass rod is sort of pushing away sphere B and pulling sphere A towards it. At the same time, sphere A and B end up splitting apart from each other. They're no longer in contact. So that's great. Now what happens is that we remove the glass rod, the positively charged glass rod. Once we do that, the two spheres are at a distance from each other. They're split apart, and they're sort of like the negative charges in sphere A sort of move to the right hand side of sphere A, and the positive charges of sphere B move to the left hand side of sphere B. Because again, opposite charges tend to attract one another. But this is sort of where everything stops. We've charged both of these spheres by induction. And so now the next step after this one would be that the charges in these spheres aren't strong enough to bring the spheres back together, to bring them back into contact. So the last step, what would happen at the very end is that you'd have sphere A and you'd have sphere B, and sphere A would become uniformly charged. So that means that the negative charges in sphere A would sort of distribute all over the place. They wouldn't stay in one specific region of sphere A. So we'd have something like this. And that would sort of be charging by induction using an insulator, a charged insulator, a glass rod, to charge other spheres, because the two spheres are metallic, so they like to allow the flow of electrons. Combined with the fact that the sphere itself is also charged, these two aspects help us find a way to charge two spheres and then make them separate from each other, and we end up creating two spheres that are charged. I hope this helps.